sure you know about the word association game, where I say a word and you have to respond with the first word that comes to your mind. So humor me for a second. What is the word that comes to your mind when I say hydrogen? In all probability, the first word that came to you was bomb. And not without reason. The sheer potential of a hydrogen bomb to cause a disaster sends shivers down our spines, making our subconscious minds remember the association. But otherwise, most of us do not think of hydrogen as a dangerous substance, which is a huge mistake because there is a place in our facilities where a hydrogen explosion is a distinct possibility, and that is the battery room. Unfortunately, many of us do not pay adequate attention to this massive risk that undeniably exists in our facilities. Hello, this is Varinder and I welcome you to another session of Tech Talks. If you're liking my videos on facilities management, do subscribe to the channel and don't forget to press the bell icon so that you get the notification when videos are released. Today I'm going to talk about hydrogen evolution in batteries and why having a good ventilation system in a battery room is important. As facility managers, managing risk is one of our primary responsibility, and we should constantly be looking out for risks and addressing them as soon as possible. Lead acid batteries release hydrogen as part of the chemical reaction during the charging process. Usually the amount of gas released is not much, but under certain conditions like thermal runaway, high charging current, over voltage, high temperature, short circuit, etc., the amount of hydrogen released can go up considerably. Obviously, the more the number of batteries or battery strengths, the more is the quantity of hydrogen released. Wet cell batteries release a higher amount, but even the VRLA batteries, which use the oxygen recombination philosophy, release hydrogen because the recombination cycle is not always 100% efficient. That is why the valves are provided in the first place. Again, under fault conditions, the amount of gas released can go up, even in the case of VRLA batteries. Hydrogen is an explosive gas with a LEL or lower explosive limit of only 4%, which means that it only needs a 4% concentration in air to support and cause combustion. Also, the hydrogen air mixture requires very less energy to ignite, so less that it is 1/10 of the energy required to ignite a petrol air mixture, and a mere spark can ignite the hydrogen in the air. To make matters worse, the gas is colorless and odorless, making it difficult to detect its presence manually through our senses. It is also lighter than air, and that means it would float up towards the ceiling, and if the ventilation is not effective, a buildup can take place. Furthermore, all our cables and lighting are also close to the ceilings, and unless properly designed, the ventilation system will not effectively remove or dilute the hydrogen concentration. I am myself witness to battery rooms created out of normal rooms with no or minimal ventilation, and no review of ventilation design being undertaken while adding batteries or even battery strengths in an existing room. These are dangerous practices. In order to mitigate the risk of a hydrogen explosion in the battery room, ventilation plays a huge role. A correctly designed ventilation system with adequate number of air changes per hour can largely reduce the risk. We need to make sure, and the fire safety codes also recommend this, that while calculating the ventilation requirement, we introduce a factor of safety of 4 or 5, which means that for a 4% lower explosive limit of hydrogen, we should design the system for a maximum of 0.8 to 1% of hydrogen concentration. Ideally, the ventilation system should be standalone, independent of the larger ventilation system of the facility. The ventilation system should also ensure air mobility from all areas of the room, including ceilings. A hydrogen sensor obviously makes a lot of sense for advanced warning. And the charging system should also be interfaced with the ventilation so that charging stops in case of a ventilation system failure. Other things that you can do to mitigate the risk are to have an active battery monitoring system so that any discrepancies in performance of battery or the battery health are flagged at early stages. The float charge should never exceed 2.3 volts per cell, and the equalization charge should not exceed 2.4 volts per cell. The ideal temperature is 25 degrees Celsius to be maintained in the battery room while charging. Batteries should never be charged in extremely hot temperature exceeding 50 degrees Celsius. Adequate spacing obviously should be provided between batteries to ensure heat removal in an efficient manner. Do not have any unnecessary equipment or material in the battery room. Limit it to only the charging equipment, lighting and ventilation. Limit the creation of static electricity, that should help. The ceiling also should be flat so that there are no pockets which can accumulate hydrogen. Light fittings should preferably be on the wall rather than on the ceiling and away from the batteries. If it is unavoidable, then the light fittings can be suspended from the ceiling, ensuring they are at least 50 centimeters below the ceiling level, and again, not directly on top of the batteries. The light fixture should be intrinsically safe, closed type, flame-proof design. Finally, while many folks would say that VRLA batteries are safe, emit lower levels of hydrogen, and do not require additional ventilation, please note the fine print, which is under normal conditions. So, irrespective of what they say, you should take precautions to avoid a hydrogen buildup, calculate or validate the ventilation requirements, do not create battery rooms without design considerations, or add batteries without first having assessed the feasibility from a ventilation perspective. Remember that there are many documented fire incidents caused due to VRLA batteries, and a battery room with poor ventilation is an accident waiting to happen. This is it from me for now. Till next time, this is Varinder signing off.